I decided to do another construction video just to give some more pro tips about how to make things work quickly in GeoGebra. So I'm actually doing the exterior angle theorem proof, and I'll just tell you what I'm trying to do. I want to extend this line. Okay, and it'd be fine. I could go out here and I could create the line BC, and then I could put a point on it, and that would work. But there's another way to get it out there without creating all those excess lines, and that's what I'm going to show right now. So think of it this way. Actually, let me show you what I'm going to do, then I'll accomplish it, right? So I can say line BC, but I need it to intersect with something, okay? So what I'm going to do is I'm going to create a circle just so it'll intersect somewhere. That's what I need. I just want it to intersect out there somewhere. And so I can use the intersect tool to grab this point, and I can call it whatever I want. I'm going to call it D. And if I just let since I've created A, B, and C, if I just let the computer name it, it'll name it D. But that's what I want to accomplish. And I can do it all in one command, and let's show you that here. So I'm going to do intersect, right? Well, the first thing I want to intersect is this line through AB. And the second thing I want to intersect is the circle that has the center C and also goes through the point A. And wait, no, C and A. And you have the option to get, wait. Oh, I see what I'm doing. This line that I want is BC. I did AB. It's doing the right thing, but I want BC. And then the circle through CA. And let me just hit enter, and you'll see that there are two. Okay, it's drawn two intersection points, and it numbers them 1 and 2. Okay, and so I'm going to go back in. I'm going to do this again because here's what I want, and I've gotten both of them, right? So let me delete them both now that I've got it figured out, right? I'm going to say that the point D equals intersect, right, the line AB and the circle that goes through C comma A. I still have that wrong line. I need to do the line BC. And I've got two options you'll see here. So I can do a comma 2, and it will just keep the second one there. So you see that D equals, it's going to create a point called D, and it's going to be at the intersection of the line BC and the circle CA. And see, if I put the 1 there, it grabs the one that's on the line, BC, that's on the triangle, right? If I grab 2, it grabs that other one that's over there to the right. So this is pretty cool because now I have the line that I can do whatever I want with, the point that I can do whatever I want with, and I don't have a circle that I have to hide, and I don't have a line that I have to hide. So that's pro tip number 1. Okay, so the next thing I'm going to do here is I'm going to create the midpoint, which is easy. But what I want to do is I want to draw a line through the midpoint so that it lands at a point E up here, so that M is also the midpoint of these segments. So M is constructed to be the midpoint of AC, but then I want to extend a line B through it all the way out to E so that M, this point, is also the midpoint of the new line that I draw. Okay, so let's do that. So first thing I do is I say, hey, I want point M, right? So point M to be the midpoint of AC. AC, okay. I was trying to figure out why I jumped off there. All right. And now what I want to do to find this point is what I did before, right? I'm going to intersect the line BM and the circle M that goes through B. So this BE will be a diameter of the circle, and let me just show you. So let's see. So I want to intersect the line. Let's see if I can draw the right line. So this is line BM, and I want to intersect the circle that has its center at M and also goes through B. And if you notice, at the moment, there's actually a point drawn inside the green one that I have. And if I come back here to this, I can edit it and put in a 2, and that will get me the point over there. And let's see if I can delete this one. Will it just call it E? No. So, all right. What happened was it created both of them because I didn't specify 2. I jumped out to circle this point. But I can delete and do the same thing again. So just to show you, that was the point E equals the intersection of the line B comma M and the circle, which I do center, which is M, and radius, or a point on the circle, B. It's got 2 options, but I jump out here and go 2 before I close the parentheses, and then I just get one of the 2 intersection points. So that's, again, a nice way to not have to draw the circle. I can get these points without having the extraneous lines in my drawing to deal with. This is a little bit of planning ahead that you'll do once you get used to how the checkboxes work. So the checkboxes, when you define them, are lowercase letters. But we're already using a lot of lowercase letters. I created I need this line segment, I need this line segment. I'm going to end up creating this line segment. And also, since they're congruent, because this is a midpoint, I'll need 2 line segments here so I can mark them as congruent. So I have about 6 line segments or something that I'm going to create all total. And if I do that, they're all going to be lowercase letters. But then I'm going to get weird names or labels for my checkboxes when I start to do my proof. And I would prefer them to be things like J, K, L, M, N, O, P, right? Those are fairly easy to deal with. So the problem isn't how it creates. I just want to give these line segments some names. And so I can use the $math or LaTeX formula. I don't know if you could see, but I typed the L and an underscore 1. And when you put in the underscore, it just translates that as a subscript. All right. So, and then if I just name all of these things, these segments, L sub 2, for example, L subscript 2, then I can create all of these line segments, and when I start creating checkboxes, they'll be named lowercase letters. There's lots of lowercase letters for them to be named, and it'll be a lot easier to deal with. So once I've decided on that, it's a lot easier just to do the L underscore 3 right arrow to get it back up on the main line rather than down in the subscript. So L3 equals, and then I can just start making these segments. I need segment A comma M, and I need L4. We'll make that segment M comma C. We need that one. I need AD, so L underscore 5, right arrow equals segment A comma D. What else do I need? I don't need A comma D, do I? Hang on. I need segment E comma C. I know I need that one. And again, I'm just showing you how it's a lot easier. I'm saving lowercase letters to be used for my checkboxes, and just creating these segments as I need them. You can also remember, you can click on the line and you can do things like, I'm going to get rid of these labels. Sometimes they're hard to find, right? Sometimes you can actually click on the label to get a hold of it. But I may actually have to make this segment AC disappear so that I can get a hold of these to actually, change their color to whatever I want them to be, and make them big. So later I'm going to have this whole segment disappears. So you see how you can tell the difference in the oranges? Well, I'm going to use a checkbox to turn it on and then another checkbox to turn it back off so that you can only see these that'll have the mark on them. And I actually have to go to settings though to show the styling to give it a decoration that I want. This one will also be decorated that way. So that's a pro tip right there, is that if you're working on one segment and you leave the settings open, it'll jump and allow you to make this. So I want to give these some decorations, right? These are congruent, as are these. So there's just a couple of pro tips there on how to use this stuff. And you can close out the settings when you're just doing something like, oh, I want this to be a different color. And I don't know if that's the right color, but I want it to be width 10 and so forth. I don't know. This one needs to be orange and the line width of 10. So there you go. And that's right clicking on the C and pulling it down. So just some pro tips on how to make that sort of stuff work. So here's another tip. So what's happening here is we can actually prove using SAS that these two triangles are congruent. So I won't do that proof right now, but what it means for me is that this angle is congruent to the angle that I just created. And I don't know if you can quite see. Let me pull this out. So that's alpha. All right. Well, that's fine. Just for drill, I don't know if I'll use it, but I'd like to name the congruent angle alpha prime. So alpha and alpha prime will have the same measure. Okay. But there's no way to do it. If you start typing alpha equals, you'll get the whole word alpha as the name of this angle. And so there's not a good way in here on the keyboard. I mean, you can press this keyboard thing here and grab alpha, but I was just going to show you a trick. One thing you can do is that you can go to the label, show label area here, and I don't really want to show it so I can actually get it off. But what I can do is I can do copy, right? Edit copy. And then when I come down here, I can do edit paste, or control V is what I did. I'm on a PC, so control V is edit paste. And now I have alpha, I put in the single quote, so I have alpha prime equals, and now I can make my angle, and I believe, well, let's see, it's BAC is what I want, right. And now it's created the angle, and it's named it alpha prime. So that's another trick if you want to name an angle something prime, just with the Greek letters. You can get them out of the little thing down here, but sometimes it's hard to figure out where I'm supposed to go. A, B, C, and then Greek, and then this. Or hey, why don't you just go to the label and copy paste it out of the label? So I just about have the figure that I want drawn. By the way, remember that the way I've constructed it, everything can move. So once I get it, you want to kind of position your figure where the things that you want to display are kind of shown where people can see them and they make sense, right? Some things won't move because this was a dependent, right? It's a child. It was constructed based on the parent M and B, and then this circle. So certain things will move. But again, you want to make sure, and this is a good way to check that you're not proving by something, like I might get confused if I left this somewhat perpendicular, that maybe there was something about the perpendicularity that was causing things to be true. So I'm gonna move things around where I can see everything. You get it too small, right, then you can't see this stuff in here. So just a pro tip there. And then also, I haven't created any text boxes yet. So I'm going to go through my proof in just a minute. And as I go through, then I'm going to create the checkboxes that select the different pieces of the theorem at the time. So I'll write out the whole theorem in text boxes. And the very last thing I do is put in the checkboxes. All right, so another pro tip, if I intend to type a LaTeX formula, $ math formula, I don't have to click on this to get it. I just start typing text. So here with my proofs, I'm always doing them in boldface text. So that's text BF for boldface, and then I type proof. And it knows as soon as I start using these backslashes that it's LaTeX, and I don't have to do anything other than hit OK. Wait, sorry. Let me try this again. So text and do backslash text BF proof. And there we go. I had stopped in the middle, so something screwed up there, but I can get rid of it by going here where that's jacked and just hit delete. Oops, I deleted the wrong one. So I'll leave it there. You see what to do, but I can get LaTeX in there just by starting the backslash text. Okay, I don't know if this is a pro tip or not, but I like LaTeX because it's really good for geometry, but to make it display all on one line rather than having the LaTeX pieces jump off the line, you have to use a lot of text. So backslash text to get it. So I'm saying and then I want the space there. That's important. Let triangle ABC. I want that to be arbitrary. But the problem is if I don't put text back in, you'll see what happens, right? It treats B and E and A and R and B as variables, right? So we don't want that to happen. So I've got to double click on that. And what I need to do is I need to put in another text. And the space is important. I want it there. And that's how you get this to look like this. If you don't use these, you can do this thing where you put the dollar signs in. And I'm probably going to screw things up and have to fix it here, but when you do this, let the triangle ABC be arbitrary and put the LaTeX inside the dollar signs, right? You get the ABC jumping off the line. So let's see if I can fix that. Yeah, so there we go. Just did an undo. So let triangle ABC be arbitrary, and consider. See, now this is still text, so I need to leave that open. All right, and consider either exterior angle at C, and I want to do a WOLOG here without loss of generality. All right, and I put this in, and then what I'm showing you is that this is going to be too long. So when I hit OK, right, it's way too long. But now that I've got it, I know that, I don't know exactly where I'm going to put this, but somewhere around either I need to break the line. So I can come in here and I can close out my text, and then a double backslash creates a hard return, and then I can do backslash text, and I don't want a space there because it's a hard return, and that will line up the things. Now this at C, that's I want that to actually be $ math, right? I want that to be LaTeX, so it'll show the C properly. Like WLOG, you want those to be text, right? But the actual variables or vertex names, you want those to be the actual math version. Oops, and you see that I don't have a space there, and I put the space inside the text. All right, and then that's a way to get your LaTeX and your text to work well. Okay, so here's another pro tip. I've decided that, well, one thing you want to do is you want to see what your maximum length is here, right? So I've seen that I'm getting very close to the edge right in here. So what I'd like to do is, while the figure is like this, I can drag it around. Here's a problem though. When I put in text boxes, the checkboxes don't move. So zooming in, zooming out, stuff like that. And I'm going to hit undo because I had it how I wanted it. But I can drag the figure over, right? I can get this placed better how I want. So I can drag the text boxes. So here, let me go to this top corner, the top left corner, it snaps to grid. So then I can use an up arrow to get it placed. And now I know that when this one is snaps to grid in the top, right, that'll work. And you can see that everything here is snapped to grid. So let me snap this to grid and bring it down where it'll look good to start my proof. And then I can start putting my checkboxes in. Yeah, I will run into this issue where this point is a little too far away. but that's not going to be the world's worst thing. I'll still be able to fit everything in. Um, and again, to solve the problem down at the bottom, right? So I'm going to have an issue here with my checkbox. Um, but I can fix that a little bit by just dragging this further to the left. And now I at least have fixed the problem down here, right? And I'll have to decide what to do. What I'll probably end up doing is creating my checkboxes and then just dragging this point slightly. Let's see if I can get a hold of it. Dragging this point slightly. Oh, it won't move. I have to move it based on this one. So I'll drag C a little bit to kind of put this point in between some checkboxes, right? So you'll see that in the proof. So that's the last bit. Now I'm just going to do the, oh wait, I will show you the checkboxes because I'm going to turn some things on and off as we go. Okay, so I'll show you the checkboxes. So my first step is I create my first checkbox. I know that this is text box 1, right? I created them in this order. So this is text box 2, proof is text box 3, so the text that goes right here is text box 4. So I grab text box 4 and then ABC and then these line segments, and I just test it real quick to make sure that it's doing what I expect it to. Okay, so this is what I mean by create your whole figure and then see what pieces of it you need to go with each checkbox. Okay, so you'll notice that I have this want to show here, right? That, oops, didn't really mean to move it, but I can snap it back to grid. That the angle ABD, right? This is, wait, I'm sorry, that I need to fix that. We want to show that ACD is bigger than BAC. Okay, so I'll fix that. But what I'd like to do is I'd like to refer to these angles. But at the moment I don't, or at the moment that I'm showing them first, I don't want to display alpha and beta and alpha prime. So what I'm going to do is I'm going to create 2 additional angles, and they will display, and then when I want to show these angles, they'll hide. Okay, so that's what we're going to do, and I'll be back in a minute. Okay, so you might be able to see now that I've created this angle gamma, which is up here, and this angle epsilon, which is in here. And sometimes they're hard to grab when they're like that, so I'll just show you that you can also go into the settings right here. And so I want them to show up when I show the want to show. Let me point that out, right? So the want to show, I want these angles that I've just created to show up, but I'd already created the checkbox, so I can't select it. So what do I do? Well, I can go to the settings, and I know that the checkbox I want them to show up with is named C. So I can go to settings and advanced and tell it to show up with checkbox C. And you'll see that I'm clicking here. I don't know if you can see that, but I'm clicking after the C. It takes about a second for it to register this condition. So if you hit the X here too quickly, it won't take. But now you can see when I click on that, that it is bringing both the text and the angle I want to highlight in. And I also want to do that. That was gamma, so I want to run in here and do the same thing for epsilon and put it also as condition to show object is C. And there you go. So now I have that part working, and then I'll have them turn off here in a minute when I get the checkboxes displayed that turn on these other angles, right? That have the measured angle pieces. I'll be back to show that in a minute. Funny story here, my proof wasn't complete. I need a step between these, so I'm pausing to do that. I never constructed this midpoint in my proof, and that's what I've got to do now. And here's the reason that it's really helpful to name your angles and your lines if you're going to use them later. I know these are gamma and eta. It's also sometimes hard to grab these things that we need. You'll see here in a second why I'm doing this. Right, so I'm creating the checkbox, which I believe is checkbox 9, that says this vertical angles thing. So I want to grab these guys. But the problem is that when you do your checkbox and you start putting it in, the the figure comes up right over what you're trying to do. But I know that I want gamma, and I want eta, and I also want, I believe it's text 9, which is just off the screen down there. And so then when you've done the checkbox, you can just go right back to the top, go to move, and check to see that you got what you wanted. And I grabbed the wrong ones. That's funny. Um, so let me see what these are. I can click on it and go, oh, it was gamma and gamma prime. And I grabbed delta, and what did I grab? That's funny. Let's go here. Oh yeah, I grabbed delta and epsilon, and what I wanted to grab was gamma and gamma prime there. So that's not hard to fix. It happens in the settings, which is fairly easy to get to a couple different ways, but I can go to advanced condition to show object. That's going to happen on K, and fix this one, go to settings, and that's going to happen on K. All right. And now the ones, the delta and the epsilon that I screwed up, I'm going to have to go into a different way because I can't really get to them on the drawing. They're hidden behind things. So when that's the case, I can go in this way. And I just want to delete the condition to show object there, and also epsilon, not delete the figure, but go to settings and advanced and delete the show object. So I'm not quite sure what happened there. Did I do one and not the other? Let me check delta and make sure. Okay, so those are both unchecked. And now when I go back to move option, I should be able to check this and get the right stuff. Okay, so all right, so this one, settings, needs to happen on K. All right, and X out of that. So I at least have the orange stuff going, and now I have to try to get, I don't know exactly what's going on. It's supposed to be a pro tips video, so let's go to settings and advanced, and it's still showing K. So let's hit delete and then enter, okay, to make sure that we get that turned all the way off. And then I'm going to go into this one, settings and advanced. And it's not showing that condition there, so hopefully that one's all the way off. Let's see what we've got now. Now I still have this one coming on, so let's see. It is this epsilon. And when I go to the settings, so this happens sometimes. You think you're clicking on the right thing, and you think you're doing something like backspace, and then I hit enter. See, it's coming back on. So backspace tab, maybe? Okay, so backspace and then tab. It finally cleared that value for me. And now when I click, oh, it didn't clear that. So I will admit that this can be a pain. I want to get rid of this. I'm just going to hit backspace. I'm going to wait a minute and click in this box because I need it to register that I've deleted that. And there we go. So now that's finally happening. Although it's kind of funny because I also picked up this one that's turning on and off. So that was the one that I must have changed to K, right? So it won't be the right thing, but I will hit backspace. What is it supposed to show up? It looks like E is what it's supposed to show up with. So I'm going to try an E in there. And let's see. Okay, so now only the stuff that's showing up, although I got the wrong one. Anyway, so this is what you do. You have to play around with it. And I thought I'd show this part where I was screwing up. It's supposed to be a pro tips video, but you do have to do some trial and error. Okay, so the final thing I'm going to show here is the fact that when I click this box, I want the new measured angles with the marks on them to show up, and I want those purple angles to disappear. Okay, so I'm going to, again, these are in front, so it's really hard to get a hold of those purple angles, so I'm going to disappear them for the moment, and then I can click right here, and it's M, right? I'm looking at the name of this checkbox, okay, because I want it to disappear on M. So here we go. We're going to click on this and go to settings. Now it's already showing up. We already have it set to show up on C. So what we're going to do is type C and not So the double ampersand is the and then not M. Right now, when you go out of this, you'll see that hopefully this works. Yep, the one that I wanted to is going away, right? And let's go back in and check it out and see what the computer's done. So advanced. Notice that it changes to that logical notation. So I'll put a link down below to the place you can get those Boolean characters, right? But I used double ampersand for the and, I used exclamation point for the not, and you can use for the or is the double vertical lines. So those are the main ones. And that's how you get it to turn on and off using checkboxes. Okay, so I've got this working and I just double checked. I did find one thing I had to fix. One stray text box was not disappearing and reappearing the way I wanted it to. So now that I know that everything works, now I'm going to turn everything back on, and then I need to space out. So I'm not going to show you the whole process, but I know that I can snap to grid down here, and maybe this one will snap to grid. This will be somewhere in the middle. If I snap to grid here, will this fit in, right? So I'm just finding different places that these will go, and trying to get them, you know, somewhat consistent spacing wise. This can go up, this can go here. So that's what I'll do is I'll focus on this. Now you'll see that I have a slight issue with this one. So anyway, that's what I do though. I play around and see what kind of space I have, and then I have to readjust my text boxes so everything will fit. All right, so I've used the snap to grid feature to place things like this, right? So let it snap to grid, and then I can use the up arrow to get the top of its box about even with this minor grid line. So the final thing I was going to show you is that I just created this line just to help me get the text boxes in here. Wait, so let me not uncheck the box so I can get it. I want to get it about even on the left with the green line, and then get it, you know, approximately even with vertically with its thing on the right. So yeah, just another tip. And so this will be interesting now that you saw all the things that I was doing to create this construction, and I hope you enjoy watching the proof here in a minute. I hope you learned something. So we'll begin our proof by letting an arbitrary triangle exist. And we're just going to label its longest side AC. It doesn't matter which side is its longest side. It doesn't matter if it's isosceles. We'll just choose one of its longest sides, and that will work. And just to point out that if we'd picked any other side, we're done already. If AC isn't the longest side, right, then either this one is longer or this one is. So the inequality is trivially true. If we don't pick the longest side. So here's one of those, this is why I'm doing the proof rather than you guys. It's one of those proofs where you have to kind of understand the construction. And we're going to use the isosceles triangle theorem here. So what's the idea? We are going to extend the line AB, right? And by the way, you can do it as well with CB, so it's sort of without loss of generality here. But we're going to pick one of the sides that's not the longest. We're going to extend it. We're going to make sure that the part we extend has the exact same length as this segment does. All right. And again, we're allowed to do that by the ruler postulate. I can create the line AB that goes through this whole, that goes here. And then I'm choosing by the ruler postulate to put D exactly R units from B. Well, what's R units? Well, R units is from the distance postulate. The distance postulate says that B and C, there's a real number that corresponds to the distance between B and C. So I'm using the distance postulate to get that measure and the ruler postulate to place D on here exactly R units from B. Okay, and you can see that we're going to end up with an isosceles triangle here. And because it's isosceles, we will get that these angles are congruent. And you can see I didn't put congruent, I said the measure of the two angles is the same. All right. So now look what we're doing. So we are trying to prove that the distance AB plus BC is greater than AC, but we don't have that, right? This is AB plus BC. The whole point though was if I create a segment AD with BD equal to this length, right, then the segment AD has exactly this length, right? So I'm basically making a segment AD that's exactly equal to the left-hand side that I'm trying to prove. And it should be clear why I'm going to use substitution here when I get this going on, but right now I'm going to use theorem 10. So this is the point where I say that I mistakenly put theorem 10 too late. I'm using theorem 10 to prove what's in the notes, theorem 6. When you're not, and we're not allowed to do that, but I could have put it earlier. And anyway, I'm going to use it because that's the only thing I have right now that gets me something like one length is longer than another. And what's theorem 10? Theorem 10 says that in a scaling triangle, the largest angle is across from the largest side, and the angle with the smallest measure is across from the side, is opposite the side with the smallest length, the least distance between its endpoints. Okay, so, well, if that's true, I'm going to look at this big triangle. I'm going to say, hey, I know that AC is my longest side, right? And so I mean that was part of the given. So what am I going to do? Well, look. So we're looking at the angle ACD, right, which is this angle. And we know that that angle is bigger than BCD, right? Why? Well, because they both share the rays CD, and then B, right, is interior, right? I can pick an interior point AD, and I know it's interior because it's on a line segment that has endpoints on these two rays of ACD. So since this angle BCD is, since this point here, call it P or whatever, since point P, oh wait, point B is what we said, right? Since B is interior to AD, then we know that this angle is smaller, right? That's the angle addition postulate. Okay. Well, what does it mean that this one is smaller? Well, nothing, but the fact that it is equal in measure to this other angle, that helps us. Now I have this angle ADC, and I have this angle ACB, and I know that ACB has to be longer. Therefore, the side across from it is longer than the side across from this smaller angle. Okay, so what do I know? I know that that AD, side AD is longer than side AC in the big triangle. Well, now I just get to use substitution, right? Because I have what I need as long as I know what AD is equal to, right? We know what AD is equal to right here. So I can substitute in the right-hand side. And that's where I'm getting this A, B, C, D just by substitution. And that is what we wanted to show. So we are done with the proof.